Now we're going to look at using distributivity to make multiplication easier. I've represented 15 multiplied by 3 as an array. 3, this factor, and 15, this factor. Understanding distributivity will allow you to do calculations like this in your head. It will also help you understand short and long multiplication a lot better. What we can do to find the total number of dots in this array, which is equal, or is the product of 15 multiplied by 3, is to partition it into, well, we could partition it into as many pieces as we want, but we're going to partition it using our knowledge of place value. 15 can be partitioned into 10 and 5. So 15, this factor, is this edge here, so we're going to partition it into 10 and 5. So 1, 2, 3, 4, 5. Now you can see that our large array that represented 15 multiplied by 3 has now been split into, or partitioned into, two smaller arrays. This array is 3 tall and 10 wide, so we could do 10 times 3, and this one is 3 tall and 5 wide, so we'd do this one as 5 times 3. You can still see that all together though it is still 3 times 15, so 10 times 3 equals 30. So you know in this part this is actually a partial product of 15 times 3. This partial product is 30, and this partial product, 5 times 3, is 15. And to find the total product, all we need to do is 30 added to 15, which is 45. So we know that 15 multiplied by 3 is 45, because 15 times 3 is the same as 10 times 3 added to 5 times 3. And we can see that our 15 has been partitioned into a 10 and a 5. Now, drawing an array can be quite slow and cumbersome, so we're going to look at another way we could represent this partitioning. Here we have our two factors, 17 and 3, and we're going to represent this multiplication as an area model. Now, an area model, basically we're just drawing a rectangle to excuse me, a rectangle to represent the multiplication. It doesn't need to be to scale, this is just to help us represent it. So that side's going to be my 3, and then that could be my 17. So here we have our two factors, 17 and 3, and the area of this rectangle represents the product of this multiplication. Which of these two factors would you partition to make this easier? If you said the 17, I agree with you, so we'd partition the 17 into a 10 and a 7. So the 10 and the 7 are the parts of our 17. So now we've got our area model that has been broken down into two smaller rectangles, and we can write the multiplication each of these rectangles represents. So this one would be 10 times 3, or 3 times 10. And this one would be 7 times 3, or 3 times 7. So what we've done is we've distributed our 17 times 3 into 10 times 3 and 7 times 3. So now we can work out our partial products. So 10 times 3 is 30. 7 times 3 is 21. Then to find our product we need to recombine these partial products, so that would give us 51. So the product of 17 and 3 is 51. Obviously, you don't need to draw an area model to help you. You should begin with a bit of practice to be able to do this without representing it. So we could do, let's do 17 times 3 again. So you might want to do jottings like this to help you. So we're going to still partition the same fact. We're going to partition the 17. So we're going to partition it into 10 times 3, which we already know is 30. That's our first partial product. And then the 7 gives us 7 times 3, which we already know is 21, which is our second partial product. And then we need to recombine our partial products to find our product. So 30 and 21 is 51. How would you choose to partition 24 multiplied by 8? What would you do to make that easier and to allow you to do it mentally? Hopefully you said that you would partition it into 20 times 8 and 4 times 8. 20 times 8, well 2 times 8 is 16, but then we need to multiply it by the 10, so 160. 4 times 8 is 32. So 24 times 8 is 160, add 32. So 160 add 32, which is a nice easy addition to do in our head, is 192. Now you're not limited to multiplying 2 digits by 1 digit. You might be able to do 3 digits multiplied by 1 digit in your head, using distributivity again. So let's use our knowledge of place value and partitioning to make this into some smaller chunks that are easier for us to manage. This 3 represents 300. 300 times 5 is 1,500. That 4 represents 40. 40 times 5 is 200. And then this 5 is 5 ones. 5 times 5 is 25. Then you should see that these numbers are nice and easy to add up in our head. 1,500 at 200 is 1,700 at 25 is 1,725. So 345 times 5 is 1,725. So hopefully you can see that our 345 has been partitioned into 340 and 5. We haven't partitioned this factor, so we just kept it as 5 all the way through. And here we have our 3 partial products, 1,500, 200 and 25. And here is the product for this multiplication. How would you partition this multiplication? Hopefully you said you would do 400 times 6. 20 times 6 and 5 times 6. So that altogether you would have 425 times 6. What would the next step be? That's right, we'd find our partial products. 400 times 6, well 6 fours are 24. Multiply it by 100. 2 6s are 12, multiplied by the 10, 5 6s are 30. So we need to find the sum of our partial products here. I would probably add the 30 to the 121st because that makes 150. Then I'll add my 150 onto 2,400, which would give us 2,550. Now, with some practice, you should be able to do this in your head fairly quickly and quite accurately.